This question is called coin toss game. It says two players A and B alternatively toss a fair coin. A tosses the coin first, then B tosses the coin, then A, then B. The sequence of heads and tails is recorded. If there is a head followed by a tail, HT subsequence, the game ends and the person who tosses the tail wins. What is the probability that A wins the game? So like, let's say like A and B are playing the game. If it's like heads, tails, right? Whoever flips his tails wins. So for example, person A flips, right? And then person B flips the tails here, then B wins. If person A flips the heads, person B flips tails, person A flips tails, person B flips heads, person A flips flips tails, sorry, then A wins because there's an HT sequence here, and whoever flipped the T in that HT sequence is a winner. In this case, the T in the HT sequence was B, and in this case, the T in the HT sequence was A. So now, we want to find the probability of A, which is probability of A winning. To do this, we're going to partition the sample space into the chance of A winning given the first flip is heads, and the chance of A winning given the first flip is tails. And with the law of total probability, we can get A by itself. The law of total probability says that the A is the weighted sum of its partitioned sample space. Yeah. So for example, I'm phasing that a little off, but I'm saying like probability of A can be considered as the probability of A given the first flip is heads times the probability of heads plus the probability of A winning, probability that A wins given the first flip is tails times the probability of tails. So we partitioned, like we have A, we partitioned it in on the middle of A winning, of A winning given the first flip is heads and A winning given the first flip is tails, and we like kind of combine them into getting A by itself again. By doing so, we can more easily find probability of A because we've like given ourselves easier subproblems rather than giving ourselves one large problem. Okay, cool. So now we're saying probability of A winning given the first flip is heads. So if the first flip is heads, then the next flip is by person B. If they flip the tails, then they win. So B wins. If person B flips a heads, right, and then we flip a tails, A wins. By we I mean A. And then if we flip a heads again, we're back to probability of A given H, right? We're back to where we started. So B wins here with probability of 1/2, right? Because the chance that we flip a tails given we flipped in heads initially is 1/2, right? Because it doesn't matter. Like tails and heads is independent regardless of the previous flip. And then here, if then person B flipped the heads after we flipped the heads, that's probability of 1/2. And then here, the chance that after we flip the heads, they flip the heads, the chance that we flip tails now is 1/4. And the chance that we get back to the probability of A given H is 1/4. So with the probability of A given H equals a 1/2 chance of So it's like probability of A winning given heads is the probability of A given heads given second flip tails times the probability of second flip tails. What does this mean? It's saying the probability of A winning given the first flip is heads, given the second flip is tails, times the probability of the second flip being tails. So we're trying to see like how does this portion of the partition outcome contribute to the overall outcome of probability of A given H. Okay, so then probability of A given H, A winning given the first flip is heads, given the second flip is tails, is 0%, right? Because we're saying the chance of A winning given B wins, basically. That's 0 times 1/2. And then it's plus probability of A given H given given second flip heads and third flip tails times the probability of that. So the probability of A winning given the first flip is heads, given the second flip is heads and the third flip is tails. So like kind of like what's the probability of A winning given this sequence of events is, well, 1, right? Guaranteed. And then what's the chance of this happening? It's 1/2 times 1/2, so it's 1/4. And then probability of A given H given, right, second flip heads and third flip heads times the probability of that. So we're partitioning the partitioned outcome space. Right, we already partitioned the outcome space with the thing we had earlier with like A, and we partitioned it with tails and heads. Now we're taking this part and partitioning it further. Right, so kind of what we're doing here. And so the probability of A winning given the first flip is heads, second flip is heads, and the third flip is heads is just back to where we began. We just got back to here, didn't we? And that was probability of A winning given heads. And since the coin flips are independent of each other, then it doesn't the run we have so far does not impact where we are now. So like it does not have memory of the flips. So like getting back to this part means like we're back to where we started basically. And with the probability of 1/4. So the probability of A given H is 1/2 times 0 plus 1/4 plus 1/4 probability of A given H. This goes away. We can subtract 1/4 probability of A given H from both sides. And so we have 3/4 probability of A given H equals 1/4 times 4/3 times 4/3 on both sides to get rid of the fraction. Cancel. So the probability of A given H is 1/3. Now I'm just going to make this less verbose for the next half because otherwise it'll take forever and there's no point. You already understand how this works. So now we're trying to find the probability of A given tails. So if the first flip is tails, and then they can flip heads or tails, and then from here, we can either win, right? 1/4 chance of 1, aka 1/4 chance of us guaranteed to win. 1 means we win, or A wins. And then here we can flip A heads. I'm getting a 1/4 chance of probability of A given H. Because now we're saying we flip the tails, they flip the heads. Now we flip the heads again, and that means we kind of got like we're back to like where we were right here, right? We're back to that point because again, it's all memoryless. So we're back here now. Again, from here we can flip heads, 1/4 chance of probability of A given H. And then if you flip a tails, if you flip a tails, then it's a 1/4 chance of probability of A given tails. Because we back to where we started here, right? So probability of A given tails is, we can combine these two, 1/4 chance of either both happening, or either happening. So then 1/2 of probability of A given H happening combined. So it's 1/4 chance of 1 plus 1/2 chance of probability of A given H plus 1/4 chance of probability of A given T. So it's 1/4. We said this was 1/3 earlier. Right, where is it? Right here. 1/4 plus 1/6 plus 1/4 probability of A given tails. All of that equals probability of A given tails. 1/4 plus 1/6 is 5/12. Subtract this from both sides. We get 3/4 probability of A given tails equals 5/12 times 4/3 times 4/3 equals 5/9. So our final equation is probability of A is 1/2, right? Where was it? 1/2 probability of A given H, which we know is 1/3, plus 1/2 probability of A given tails, which we just got as 5/9. So we have 1/6 plus 5/18, 3/18 plus 5/18, which is 8/18, which is 4/9, and that's the final answer, 4/9. So yeah, just gotta see like understand independence, understand law of total probability, and understand like when you get back to where you started, you should reuse variable names. And yeah, that is the final answer. This is like one last look over everything. It's a little laggy, but yeah, that's all.